Hello everyone, my name is Rishabh Sinha and today I am going to teach you the asymptotic analysis. So, what is asymptotic analysis? As we all know, the data structure is a way of organizing the data efficiently, and that efficiently or efficiency is measured either in terms of time or space. So, the ideal data structure is a structure that occupies the least possible time to perform all its operation and the memory space. Our focus would be on the finding the time complexity rather than space complexity, and by finding the time complexity, we can decide which data structure is best for an algorithm. So, we can say that the main question arises in our mind then on what basis should we compare the time complexity of data structures. The time complexity can be compared based on operations performed on them. So, let's consider a simple example. So, suppose we have an array of 100 elements and we want to insert new element at the beginning of the array. So, this becomes a very tedious task as we first need to shift the elements towards the right, and we will add the new element at the starting of the array. Suppose we consider the linked list as a data structure to add the elements at the beginning. The linked list contains two parts, that is data and address. We simply add the address of the first node in the new node, and head pointer will now to the newly added node. Therefore, we can conclude that the adding the data at the beginning of the linked list is faster than the arrays. In this way, we can compare the data structures and select the best possible data structures for performing the operations. Now, we will see that how to find the time complexity or running time for performing the operations. So, we can say that the measuring of the actual running time is not practical at all. The running time to perform any operation depends on the size of the input. Let's under this statement to a simple example. Suppose we have an array of 5 elements and we want to add a new element at the beginning of the array. To achieve this, we need to shift each element towards right, and suppose each element takes 1 unit of time. There are 5 elements, so 5 units of time takes 1 unit of time. There are 5 elements, so 5 units of time would be taken. Suppose there are 1000 elements in an array, then it will take obviously 1000 units of time to shift. So it concludes that time complexity depends upon the input size. Therefore, we will say that if the input size is n number, then f of n is a function of n that denotes the time complexity. Now, what are the asymptotic notations? So, mainly the common used asymptotic notations used for calculating the running time complexity of an algorithm is given below. So, as we can see in the PPT in the slide, that there are 3 asymptotic notations, right? So, first one is big O notation, and the second one is omega notation. Then the third one is theta notation. So, what is big O notation? We can say that big O notation is an asymptotic notation that measures the performance of an algorithm by simply providing the order of growth of the function. Then the second point is this notation provides an upper bound on a function which ensures that the function never grows faster than the upper bound. So it gives the least upper bound on a function so that the function never goes faster than this upper bound. So we can say that it is a formal way to express the upper boundary of an algorithm running time. It measures the worst case of time complexity or the algorithm's longest amount of time to complete this operation. Second one is omega notation. So it basically describes the best case scenario which is opposite to the big O notation. It is the formal way to represent the lower bound of an algorithm's running time. It measures the best amount of time an algorithm can possibly take to complete for the best case time complexity. It determines what is the fastest time that an algorithm can run. So, we can conclude that if we require that an algorithm takes at least certain amount of time without using an upper bound, we use big theta notation. That is the Greek letter omega. It is used to bound the growth of running time for large input size. The third one is theta notation. So we have learned that till now big O notation, omega notation, and finally the theta notation. So what is theta notation? The theta notation mainly describes the average case scenarios. It represents the realistic time complexity of an algorithm. Every time an algorithm does not perform worst or best in real-world problems, algorithms mainly fluctuate between the worst case and the best case, and this gives us the average case of the algorithm. So big theta is mainly used when the value of worst case and the best case is same. It is the formal way to express both the upper bound and lower bound of an algorithm running time. So these are the notations which we have learned. Now we will come to the most important part of the data structure, that is pointer. So what is pointer? So we will say that pointer is a variable. In short, I can say that the pointer is a variable which stores address of another variable. So let's see this pointer in a more brief manner. So what is pointer? As we can see that pointer is used to point the address of the value stored anywhere in the computer memory. To obtain the value stored at the location is known as differencing the pointer. Pointer improves the performance for repetitive process such as traversing string, lookup tables, control tables, tree structures. So how does the performance actually the pointer improves, or how the pointer improves performance for the data structure? So we will see in four ways. What is traversing string, lookup tables, the control tables, the tree structure, right? As we have learned in this slide. So what are the details of the pointer? So a pointer arithmetic. There are four arithmetic operators that can be used in pointers. So the plus, the hyphen, the plus, the hyphen. The array of pointers, what do you mean by? So we can define arrays to hold a number of pointers. So what is pointer to pointer? Now the C allows you to have pointer on a pointer and so on. The next point is passing pointers to function in C. So what is that mean? Passing an argument by reference or by address enable the passed argument to be changed in the calling function by the call function. So the final point is the return pointer from functions in C. C allows a function to return a pointer to the local variable, static variable, and dynamically allocated memory as well. So we have learned the basic concept of pointer, and we will learn more about that programming. Otherwise it will be not possible for me to teach you guys how a pointer works. It would be better for me that if I teach you the pointer in the most organized way through programming. So now the final part, we will learn about the structure. What is structure? A structure is a composite data type that defines a grouped list of variables that are to be placed under one name in a block of memory. It allows different variables to be accessed by using a single pointer to the structure. So what is the basic syntax of that? So as we can say that first will the structure underscore name, data type member 1, data type member 2, and the data type dot number of n members, right? So this is the basic structure. So what are the advantages of structure? We can say that the structure can hold variables of different data types. Then the second point is we can create objects containing different types of attributes. The third one is it allows us to reuse the data layout across all programs. And the final point is the structure is used to implement other data structures like linked list, tag, queues, tree graphs, etc. So that's all from my side for today. So as I have said that the structure is used to implement the other data structure like linked list, tags, queue, trees, graph, etc. We will learn about more about that in the next one. So till then, bye bye.